All right, good morning, everyone. Please welcome Bob Walker to the Delivery Conf stage.
That was really nice. Oh, good, my mic's on and everything. So, like you said, my name's Bob Walker. I'm the VP of Customer Success at Octopus Deploy. And today, I want to talk to you about lessons I learned automating database deployments. I will mention tangentially Octopus Deploy, but this is really more about a story of how I automated database deployments, or as part of the team that did that. Just a little bit of housekeeping before I get started. 30 minutes, there's no way I could cram everything there is to know about automating database deployments in 30 minutes or even an hour or a day. If you go to that URL, I have a series of blog posts that I've written on this particular topic, and it has getting started guides, walkthroughs, any number of different things to help you get going. If you look at the bottom right-hand corner of that screen, you'll see I have that URL, and you can go there, and that's going to appear on every slide after this. All right, so bad old days. I want to get started on telling you a story and how I did this. Or I wouldn't say just me, it was actually a collaborative effort. So let's set the stage. I didn't always work for Octopus Deploy, believe it or not. I worked for a different company back in 2014 called Farm Credit Services of America. That's a really fancy way of saying it's a credit union for farmers. And I've been promoted to a lead application developer in charge of a team that handled the retail loan origination system. And that's a really fancy way of saying it's the way that farmers get money to buy stuff. And I was really excited because a lead application developer, they're the architect of the team. They make all the technical decisions. Not only that, they get to do all like the DevOps-y type of stuff, the builds, the deployments, and that's really cool. I love doing that stuff, hence why I work where I work. That's until I got a chance to look at the loan origination system. So at any given point in time, the loan origination system has about $1 billion worth of loans flowing through it. It turns out being a farmer in America is very expensive. If you want to buy an acre of land to farm in Nebraska, it's about $30,000 to $50,000 for that, just that 1 acre. So as you can imagine, it gets pretty expensive pretty quick. And it would just randomly catch on fire. And I was like, how is this catching on fire? Well, the system was designed in 2008. And for whatever reason, they decided to duplicate a lot of the data. And you ended up in this situation where you had 700 tables. Now, best practices you follow, everything should go through store procedures back in 2008. You don't have a really good entity framework. As you can imagine, that's a ton of CRUD store procedures, or create, retrieve, update, delete. So let's solve for that problem. Let's do T4 templates, and let's auto-generate everything. But not only that, let's gold plate it to the nth extreme, and you end up with 5,000 schema objects. Now, that in and of itself isn't a problem. It's how we tracked our database changes was one of the first problems. Now, the way that teams are organized at FCSA is there is a lead developer, there is the 4 to 6 developers, give or take, and then there's a database developer. And the database developer, they're responsible for making sure the database is functioning. And that's the database developer, in case you're wondering. He's working really, really hard. And the database developer on my team, Jerry, he worked his tail off. And he was really busy, and he didn't want to do all the mundane changes because he couldn't. And so the developer would just let Jerry know, hey, I made a change, and Jerry would go, great, thanks for letting me know about that. I've added it to the list. And when I mean a list, he'd actually write it down on a piece of paper and put it on his cubicle wall. Some teams, they used Word docs or Excel spreadsheets or anything like that. How you tracked it didn't really matter. The problem was we were manually tracking it. And finally, we made it worse, if that's at all possible. Because the way we did our development and our deployments was very, very, very painful. We had 4 environments. I think every company I've ever worked for has had 4 environments. I think it's kind of funny. Dev, test, stage, prod. Developers, we were system admins in dev and test. Now the idea is that developers, they should point their code to the development SQL server and make all the changes. However, QA adds different scenarios up to test, and they would break stuff, and that's their job. So developers, they'd point their local machines over to test, they debug it, and figure out what the problem was. But they never change it back. Because test had 15 times more data than dev. And so they said, why don't we just make our changes in test first? Dev became completely optional at that particular point in time once that decision was made. So the DBAs, they're taking a look at that going, that is absolutely crazy town. One DBA, I'll talk about him in just a sec, he called it the Wild West of database deployments. So we use a tool like Redgate SQL Compare, and we generate Delta scripts for the DBAs to run because they're the only ones that have permissions to make those changes. We're manually keeping track of changes, and so we manually uncheck changes because we have changes that have been made into test that aren't ready to go to stage or prod yet because we don't have the appropriate code changes yet. So you're going through and you're checking changes and you're making sure everything's right and you're comparing your list and you're hoping and praying. And praying is not a good strategy. So 60% of the time, if we do a release, we had to do an emergency bug fix the next day. I think I'm being pretty generous with that. So this is where I say tooling to the rescue, because 60% of the time is not an acceptable answer. And what we would do is we would combine everything into one release and do one release a quarter, and it'd take us like 2 hours, 4 hours, 6 hours to do our deployment. And some teams, they had to do their deployments on weekends. Their deployments took all weekend. I can't imagine doing a database deployment that took all weekend. That sounds like a real suck fest. I lucked out I wasn't assigned to that team as lead dev. Well, here's the problem with tooling, and this is part where you're thinking to yourself, I'm going to tell you this is where you have to use Octopus Deploy, Redgate, all that other fancy stuff. That's not necessarily the case, because you may or may not have picked the right tool, because there's a lot of tools. And if you want to have a really fun time, if you're the type of person that likes to stir the pot, walk into a room such as this full of very smart technical people and say, we want to pick the best tool. And watch just everything just explode, because like when we want to pick the best build server, we're like, well, I like Jenkins. No, I like TeamCity. Well, I like ADO. Well, who's right? The answer is that everyone's right. That's the problem. So what we did is we just like, let's pick a tool. Let's try it out. And so what we did is we used SSDT, our SQL Server data tools, also known as SQL packages, also known as DAC packs, depending on however you describe it. And the way that changes are made in SSDT is you use Visual Studio to create your desired state of the database. Say, I want to add a new column onto the quote table. You can see test change right there. That's the change I made. That's why it's checked. And then you do some sort of sync command, and then that would push it up to the dev server. No, everything's great. This brings me to my first lesson. The higher the friction, the slower the adoption. And it's possible to have your friction set to be so high that you stop adoption altogether. Because the fact of the matter is, we just said, let's just use this tool, and let's try to use it within our existing process. And we caused a lot of friction doing that. And we failed. And it wasn't because the tool is bad. SSDT works. I talked to customers where SSDT is working for them right now, and their opinions may vary on whether or not how much they like it, but it works, and it's not like the tool is bad. The problem is we moved way too much cheese. And we moved way too much cheese because not only is there database developers, but there's DBAs and there's BI developers that we didn't consider. And they had to start using Visual Studio, which in and of itself isn't a bad thing. But we also asked them to stop making database changes using SSMS. And you could use SSMS, but you'd have to run like basically a reverse sync command that would sync up what you had in Visual Studio or what you have in source control. So we're asking them to change quite a bit. The other problem is we try to implement the tool and using the existing process, because a lot of people are kind of taking a wait and see approach. And you're still making changes locally, and then you're syncing them up to dev, because that's what you want to point your code to, and that's where you're going to make all your changes. Well, we didn't really have any enforcement around this, because some people would sync dev, some people would sync test, and which one's right? We had multiple truth centers. What was in test did not reflect what was in dev, did not reflect what was in source control, and it just drove everyone crazy. And we tried another tool. We tried Roundhouse, and I won't get into that. But the fact of the matter is we failed with Roundhouse as well. And when you fail multiple times, the problem might be with you. Because it's just nature of the beast. I wasn't actually expecting to laugh. Sorry, that threw me off. We needed help. because we needed something that worked for everybody. We all liked using Redgate's tooling. About 40% of the people at the company had 40% of the developers had a Redgate SQL Toolbelt license. We all liked using them. And Redgate, we happened to reach them on the right day, on the right week, on the right year. They said, not only will we help you, we'll fly out 2 of our engineers in about 2 or 3 months, and we'll sit with you for a couple of days, and we'll help you implement the tooling. And in return for that, we'll get a case study. I'm not saying you should call up Redgate and ask for that, because they're probably going to say no, because we did this in 2014. But there are consultancies that I know where people used to work at Redgate now do this type of stuff. So if you're interested, let me know, help you out. I wasn't involved with any of that. My team was picked as a pilot team because we needed to solve this particular problem. So what I wanted to do, let's hope, all right, cool. I was like, I didn't want to wait at all. 3 months, I got to solve this problem right now. So I said to myself, you know what I'm going to do is I'm going to implement this tooling right now. I'm going to show Redgate how smart I am. So let me show you what I did. Thankfully, it's just a quick video. There's no sound, so thank God for that. We get to use SSMS, but we're making all our changes in Dev. I'm adding a new column, and I can see that. That's highlighted. I can go over to the tab. It will highlight that new column that I'm adding. I select the table. It's my first time using Camtasia. I was really excited, if you can't tell. And then I save the changes, and it saved it. Everything I'm in SSMS, so that's great. Now I'm using TeamCity. I have 4 builds in TeamCity. One's actually doing the build. The other 3 are the deployments. So the first one, I need to build something, so I'm running the SQL change automation build step. I'm providing the source control folder. I'm going to be generating an artifact, or it's a NuGet package, essentially. And if you're not, NuGet packages are nothing more than glorified zip files with additional metadata. I take that package, make it an artifact that other builds can then use. Now, assuming that I have code to deploy, this is where this build would be done. But I don't have any code. I've already made my changes in Dev, so there's no changes in Dev. Test, I need to sync my changes with test, so I'm running the sync command. And just like before, I provide the necessary details. I just realized there's an issue with that package version, but neither here nor there. The server, you provide the server. Yes, I'm using SA. It's a local server. Sorry. If there's any DBAs in this room, they're probably freaking out. And then I provide the details, and there's nothing really else about that. Now, the DBAs are going, there's no way we're going to allow a build server to have access to deploy. So you need to generate Delta scripts. I'm like, OK, I can automate that as well. So I'm going to use the Redgate's tooling. I'm going to use Redgate CLI tooling. I'm going to generate the Delta scripts, just like I did before. I solved the problem, right? I solved all my automated database deployment problems. That's what I thought. Tooling is not going to fix a suboptimal process. So I didn't solve all the problems. I did solve a couple, but in a lot of cases, I was slamming my head in the door. So let's talk about the good. Dev is now required. You have to make your changes in Dev. That's what gets saved into source control, and then that's what gets synced with test. I source control the database. That's great. I now know when a change was made, who made the change, why it was made. That's cool. But I had 3 different deployment processes. I had manual changes in Dev. I'm automatically deploying to test, but I'm still generating my Delta scripts for someone else to manually run. So I've actually made my problem worse. All right, so Redgate came and visited us. It's time they needed to help us out. So over on the left, that's the DBA. That's John Morehouse. He's the one who has all these great lines like stupid simple and Wild West of database deployments. He drove a lot of this. And I would say without him, we probably wouldn't have been where we were. Next to John is Kent. Kent is the database architect. He sets all the policies, procedures, everything else that we all have to follow. In case you're wondering what I look like without a beard, that's me in the middle. Next to myself is Sean and Alex from Redgate, and then over on the far right is Jerry, the database developer. All of us had different titles within the company. The 6 of us were sequestered in a room for 2 days. It said, solve database deployments. I couldn't think of a better GIF. So first day, Redgate asked, how do you get a change from a developer's machine into production? So I pulled up TeamCity and I was going through, check out all this cool stuff that I did. Look, I solved database deployments. You just need to convince the DBAs to let TeamCity deploy to that. And I go, are you insane? Like, what are you talking about? It's like, there's no auditing. We don't know who's reviewing this change. When did this change get reviewed? I'm like, what? No, it's just automation. And then they're like, why is it different per environment? It's like, that's because the DBAs are being jerk faces. I said, no, we need to identify our core requirements. What are your core requirements? And we had a good conversation, and basically what we landed on, we needed to have a better review process. Changes cannot get into the dev server until it's been reviewed is basically what we landed on. In addition, the DBAs, they want to be able to review changes before they go to staging and prod. That's why we have those Delta scripts. So ostensibly, they're supposed to be reviewing those changes. Those were the big ones. One of the dream requirements was the DBA. They wanted to say, all I want to do is set a deployment to run at 7 p.m. because that's when we could deploy. We only operated within 4 states. So banker's hours, it's great. 7 p.m. is awesome. I once worked at a company, we can only do deployments 2 a.m. Saturday. So they just page me if there's a problem. Then we started designing the process to meet those requirements. How will we go about doing this? And we didn't focus on tooling at that particular point in time. We said we wanted to do some sort of review process. Okay, why don't we start doing feature branches? Why don't we start doing local database development instead? Because you should really treat your database like you treat your code. How you develop your database should be how you develop your code. Every developer, they're not making changes directly on dev. They're not changing that code up there. What they're doing is they're changing it on their local web server, or they have their local app server, which is their local machine. Let's run SQL Server it the same way and make your changes locally. So then you can do feature branches, you can do pull requests. But again, we're not talking about tooling, we're just talking more about the process. Then in day 2, we said, let's research and discuss the tooling. And the nice thing about having Redgate, or an expert in the room, is they can really drive those conversations. And they said, what you really need is a deployment server. A build server is not going to meet your requirements. So we did a quick POC and demo using TeamCity, Redgate, and Octopus Deploy. Camtasia again. We're doing everything locally. That's, in case if you didn't pick it up, actually I did it the first time. But now we only have 2 builds in TeamCity. We have a build, and then we're pushing up to dev in the next step. We're still running the same build step like we did before, but the big difference is what we're monitoring. What we're monitoring is all the branches. So this build is going to kick off for every single one of the branches. That includes pull requests as well as feature builds. So a database developer or a lead developer, they can go in and they can review the changes, and they can say they only allow this pull request to go through if the build is successful. If it is, take that artifact and push it up to Octopus Deploy. And that's what these 2 particular steps are doing. But only do that if the previous build that came in is from master. So you're doing all these feature branch builds, but only do this if it was from master, meaning it was successfully merged. Now you'll notice that all 4 of our environments are being deployed using the same tool. And we have the same exact process, the same 5 steps. We have a review process, we're generating a Delta script, and this is all Redgate tooling that generates this Delta script for us. But we're turning on and off the review process when we're in staging or when we're in production. And the DBAs, they got their dream requirement because they can go in and they can say, I can deploy this now or I can deploy this later. But again, this is just the requirements that we had. And the tool met what we are looking for to do. Click on deploy. This will speed it up just a little bit. And Redgate's tooling and Octopus Deploy's tooling, it's working together, and it's going to generate an Octopus Deploy artifact. That's what the Redgate tooling does. It's a HTML file that I can download, and I can take a look at that file. And so like a DBA, they can come in and go, okay, what's getting changed? Oh, we're adding some new tables. Okay, I'm okay with that static code analysis. I'm going to go ahead and I'm going to approve this. And someone can come in and they can go, yep, everything looks good. And then If you look at the bottom right, all of that's audited. Again, I worked at a bank. Auditing is key. That was their biggest thing. That was actually their only thing that they kept hammering home. Real change happened when the devs and the DBAs started working together. You can call that DevOps, you can call it whatever the hell you want to call it. But the point is that the 6 of us got in a room together, we started talking about the issues we were running into, the concerns that we have, and then we started working together and solving those problems. It wasn't us against them, it was us against this problem. Because we ended up with a better overall process. I don't need to go through all of that, you guys have already seen it. But it was great. So let's talk about the results. What happened when we started doing this? Because before we failed, we would always fail. It's like, what happened now? I didn't know this at the time, but this is the last part of our CI/CD pipeline. We had automated our code deployments up until this point, but we hadn't automated our database deployments. So I talked about how we had a 2-hour deployment window that we typically do. Now, if we're honest, it's actually 30 minutes of deployment and 90 minutes of verification. If we're really honest, it was 29 minutes of database deployments followed by 1 minute of code deployments, and then we pray in God that we got everything up and running. Now the verification, that was, again, it's an old application, and so there wasn't a lot of automated testing at that particular point in time, so everything was manual. We were trying to push that 60% down as far as we could. QA was verifying, business owners were verifying, our manager was verifying, I was verifying, the database developers verifying. We're trying to do as much as we could to avoid that 60% because we hated to do an emergency release. Because if there was a problem, that could stop a farmer from getting money, and that has a real-world impact. That dropped to 0% overnight. If a change was accepted and a pull request was accepted and merged into master as part of a change set, either that entire change set went or none of it went. That's the way that the database deployment tooling works. That's pretty much how all the database deployment tooling works, not just Redgate, because it uses transactions. Either all went or none of it went. And if none of it went, we knew why, and we could solve that problem right then and there, and we could get it back out there. Something interesting started happening. Just by automating, we got faster, because we didn't have to wait for the DBA to sign on, find the Word document. Yes, we were using Word documents that listed out all the scripts that they had to run in the right order. We didn't have to wait for all that nonsense. And we didn't have that back and forth during the verification going, John, did you run this script? And go, yeah, Jerry, I ran that script. Get off my back. So we got a little bit faster just by doing that. But after a while, we would get faster at doing our deployments just by a little bit. Like we learned the tool, we learned some tweaks and everything like that. Most database tools, most deployment tools, there's some sort of fixed cost with that. You're always going to have, it's always going to take some amount of time to do that work. That you can't really hide. But our verification time started dropping. And I'm asking our QA people, and our business owner, why are we not spending as much time as we're verifying? I mean, these are still pretty big changes. They go, well, we're not seeing the same problems that we saw in dev, in test, and staging. We're not missing the database changes like we're missing. We're not running into the same issues like we're missing. We're trusting that the process is working. We're feeling good about what we're about to deploy. We don't have that, oh God, I hope everything works moment. And so could we start deploying more often? Do we have to wait once a quarter? Could we deploy when we feel comfortable? Go, yeah. So we started cutting that down. And over time, it went from once a quarter to once every 2 months, once every 6 weeks, once a month. And we got it down to once every 10 days. And I know the dream of CI/CD is deploy to prod 10 times a day. I mean, that's everyone's dream. Work at a bank, if you tell a business owner, hey, I want to deploy to prod 10 times a day, the face that my business owner made to me was like, oh. So probably not going to be a realistic goal. But once every 10 days is a hell of a lot better than once a quarter. And we got down to 15-minute deployments. Because if you're not deploying as much, there's less to verify. There's less for the tool to deploy. That's the database deployment tools. They'll generate, oh, I need to run this script, or I need to run these scripts. Well, if you're not deploying as much, there's less scripts to run, there's less time that it takes. And you don't have to verify as much. So we got down to 15-minute deployments. came time to scale it out to all the teams because by all accounts, the pilot was successful. And expect to get pushback from unexpected places when you start scaling out. Some teams, they were on board almost right away. In fact, they were bugging me once a week after a while going, when can we get those database deployments? When can we buy the tooling? We're ready. We can see the benefits. Let's get going. Let's get going. Let's get going. So that was about half the teams on the floor. The other half, it's like we had to go around and poke them with a stick. And a lot of it was because of FUD, fear, uncertainty, and doubt. Out of the database developers, that was the thing that surprised me more than anybody because so much of the database developers' time was spent manually tracking these changes, creating these Delta scripts that they would have to manually create all these Delta scripts or unchecking and checking these boxes. It's a lot of grunt work that's very time-consuming and not very rewarding. They love that. It's like, man, I love doing that stuff. That's my bag. There's also a few of them that were very much like, I don't trust tooling. I don't trust technology. And I find that kind of funny what industry they work in. But they're like, no, I'm the only one that can make the database changes. And what I did wrong, don't do this. Don't be arrogant and say, I'm smart, you're dumb, listen to me, I know what I'm talking about. Trust me, everything works perfectly. I needed to help them build trust. And that's where I failed. I needed to walk them through the tooling and the process, sit with them, help them understand this is how the tooling works. These are the bits and pieces that you're going to have to configure. These are the things you're going to run into. Really help them out. And then we also were adding in manual interventions into the process. We would add the review step in dev and staging, and dev and test, so they could go in and they could review the changes. What's about to go out? And they feel a lot more confident about what's going out there. We also needed to adjust the process when needed because we got a lot of really good feedback from a number of different teams when we started doing this. The process is going to change. What we worked out in those 2 days, I didn't realize it at the time. I thought the process we came out of there, I thought that was the most awesome process in the history of ever. But that wasn't really the case. It was really just a rough draft. Because it went through a number of iterations. So this is a screenshot of what the process looked like when we finished. What changed didn't really matter. We started doing like auto approvals. We started only reviewing changes in staging. Started doing like backups for developers so they could get actually like that sweet testing data that they like pointing their local instances to. What changed wasn't necessarily really important. The point was that it changed. And anyone that kind of goes through this whole thing, their process will change as well. Probably not to this. But no one's going to start out like this. No one in their right mind is probably going to start out doing something like this. Which brings me to my final lesson. Identify your core requirements. Then design your process rough draft based on those requirements. And then after that, pick your tooling. I would love everyone in this room to use Redgate and Octopus Deploy and, as the preferred tooling, but you got to be pragmatic about all that. Your core requirements may or may not require you, may not point you to Octopus Deploy, and that's fine. Pick the tool that best suits your needs. Thank you very much.
We have where, let's say you need to update data, then update a proc, and then maybe update a schema as a result. Like there's some really, 800 tables and stuff like that gets complicated after a while, as you can imagine.
Absolutely.
So like that's one of those things where order becomes very important, and what part of the execution order becomes very important. Mm-hmm. And then how do you manage that and make sure that everyone's comfortable?
Yeah, so some of the tools that provide you allow you to kind of control some of that order, so you can actually write these scripts in such a way that I'm going to run this script this way. I'm going to run this script, this script, this script. But you have to write it in such a way it's like impediment or whatever you want to call it. Thank you. And basically have some brains and go, I'm going to only change this data, and I can run it 50, 60, 70 times.
But then you need to do it by environment. So you have your test data, then you have your, you don't want to touch production. Right?
Yeah, so that part gets a little bit trickier then.
So one thing I was going to say is we use SSDT in my company, and we had the same problem. And one of the ways that we deal with it is similar, is basically that same approach. And that seems pretty standard from what I see is you have an ordered set of change that you put in there. They have to be smart enough to be able to deal with variation that you might get in test and staging and prod. And generally we hook into our pre-deploy and our post-deploy, so you got your schema deploys and stuff like that, but then either pre or post, you make those changes. And you've got a separate thing that's tracking, hey, is this script run, right? And so it knows the order. And so, we switched to that probably about 3 years ago as opposed to a previous horrific solution that we were using before. And that has served us really, really well. It's been really, really solid, and it's just one idea. Sorry, I guess I should. We're not supposed to hold it.
Hi. So I was just wondering, did you have to do any sort of like cultural change around backwards and compatible changes and like thinking about that a lot more since you moved to continuous delivery?
Yeah, cultural changes, yeah, absolutely. So it took a lot of people, specifically the database developers, because they hadn't done CI/CD. All the regular developers, we've been doing pretty much CI/CD for quite some time. We've always been building our code. We've always been deploying our code, be a build server or maybe a deployment server. But it was really kind of more the education around what is Git, what is CI/CD, why do you want to do something like this? And that was one of the things that we kind of had to go through as well. So there was a bit of organizational change around that as well. So you kind of we almost had a budget in that time, and we were dumb about that. That's a really good point.
Yeah, so like one of the things we struggle with is we're kind of trying to get into a place where we can asynchronously run our migrations such that they're not actually tied to the code going out. And so one of the challenges we struggle with a lot, especially because we use Rails for our ORM for most things, is that it's very difficult to get it to not be aware of certain things. Then how do you make sure that it's a very large cultural shift to get everyone to think about being able to write code that can go out at 2 p.m. that might rely on database migrations that's going to run in 3 days. That is one of our bigger challenges that we're facing, and it's definitely more cultural than tooling. Feature flags don't help when Rails interprets the table and says, oh, I see these columns, or oh, I don't see these columns, or oh, I think this is supposed to be there. And so we have to do a lot of tricking with the framework. We're almost fighting against it. And so it's a lot of code and cultural changes of how we process and think about our code.
So that raises another issue. You talked about having your database schema as a completely separate package, almost as a piece of software in its own right, that you were deploying independently, so that you weren't aware of the dependencies in the versions of an application going out. We do the same thing at the moment. Database version is completely independent, but it leaves us in this similar problem. How do we make sure that the database version goes out before the software version when you're deploying, we have 30, 40 different services leaning on the same database?
I was going to say, the point that Jonathan's talking about the ORM is that that's one of the things that limits you in having them separate packages, but you have the dependency there. I can tell that bothers me.
As I say, most of the time I like doing the code. I like doing the database deployment before the code deploys, because I think that solves some of the problem you might run into. I don't think I've ever seen a situation. That's the first time I've ever heard of someone deploying code before the database change. That's very interesting.
I think that's right. I think you can do it if you completely decouple your database from your code, and you have to make your code aware of what the schema should look like, and what stage is at. And I've used something where we've versioned every row in a SQL database, so that I'm on version 1, and the code knows how to work with that, and now the code's looking for version 2, and if it's there, it does the migration in place, and you have an out-of-band process that does something similar. And then the other way to fix it is to not use a relational database.
That's I almost said that. I was like, you could do NoSQL and you kind of solve some of that. But you could also, there's also some of those, you can do kind of the that interface layer that's really like views or store procedures that sit between the direct table access. And it really depends on.
How did that work for you with version data?
It worked pretty well, but it was all, it worked well. We didn't leverage the ORM we had at the time. I think no one wanted to touch it. I can't remember. So we had to write a lot of that logic in a layer that existed above the ORM, I guess, I don't know if it's a database access layer, whatever we called it, I don't remember. But it was good as long as you had that out-of-band process that was going and moving the data from, say, version 1 to version 2. because obviously at some point you don't want to keep on every database call having to do this check, and then with feature flags you could turn that off at some point.
Well, one of the things I was going to say, I think you mentioned like, hey, what happens when you have a database that has 30 or 40 services that are based, like one of the challenges we see, and I think this is kind of like we see in the industry with microservice, kind of patterns is trying to establish a bounded context around your data. And so one of the challenges we have is we have a legacy monolithic database structure, and we're starting to, break down into a bunch of microservices, and it's thinking, well, how can we start to break down our monolithic database? And that's really one of the challenges I want to bring. That's the challenge. How do you go from deploying this database the same, and what kind of steps do you do to get to where you can, now you have, the 5 or 6 different services or more that this database now, serves, and how do you start to break it apart so that they can start to ship, hey, this microservice, or whether it's micro or not, this service can ship with its database changes and these changes and these changes, so they can ship independently. Otherwise, you do have, the challenge we have is you do have to coordinate database changes, and it becomes harder for each service to ship independently whenever they want if you got somebody else that has a database change that's in the middle and aren't ready. And we don't know, we're not sure. So that's my challenge.
I'd say I was going to say to what you're saying is like referential integrity becomes like, that's something we're all kind of core on, especially like with banking. Your RDMS is supposed to be that your data can't break, right? And so when you try to decouple, especially like when you look at some of these things, what a database is used for, one, you're doing data entry and retrieval, but then a lot of times we use it for reporting as well and doing initial analysis, like you said, 40 other services that are doing something with it.
Yeah. And even if you keep we've even looked at if you even keeping the structure and everything the same, so the dependencies don't break on that. But how do the teams actually think about, well, we used to do it this way, and so is there a way that we can continue to keep the structure all the same, even maybe deploying into the same database, different schemas or something like that, so we're not breaking some of those reportings, but that each of them still can be deploying only the changes to the tables or whatever the objects that they own in there. Are there some patterns there or ways of solving that problem where even if we have to stay in the same database, we can still kind of have a bounded context that those are tables that this service is the only one that changes?
So I think sorry, 1 second. That's a good transition into what successes have we all had in this area.
I was just going to say, I think you answered the question yourself by breaking stuff down into those microservices. If you can find out where you don't have those references anymore, and that's how you compass and break up your microservice, then isn't that kind of what you were saying? I think you answered the question. It sounded like you answered your own question.
Yeah, well, I would add that it becomes harder when you realize that there are technical challenges there with the way you deploy. If you're deploying to a PaaS service or kind of like a software as a service where you got we deploy software to individual clients and things like that. So in some ways we're carrying things forward, right? And so we've got to think, well, how can they do that and not have to coordinate the order? So there's some challenges there, not being able to kind of just say, oh, it's separate, one instance.
Yeah, I think so. In my experience, when you start moving towards microservices, I think the first thing that happens is you don't even touch the database. That's the first thing that happens. And then over time, you realize that, hey, this microservice is only working with these 10 or 15 or 100 tables. And then that's the opportunity, that's the right time to obviously break it up, because now you've completely decoupled it from the rest of all the other tables and schemas that you have.
I mean, you're not necessarily moving to microservices. You're more moving to SOA-based architecture at that point. Because you kind of, kind of back to your point, but I think that's a really good way to look at it. It's like, okay, before I used to hit the database directly to get this data. Now I'm going to hit this service.
Yes.
And that's...
Is that like Saga pattern comes in and stuff?
Yeah, so the two things I've heard is like if you're building out multiple services, like none of them can ever share the same data source. Like you just don't. It's like, okay, we're going to pull this out and like this is its own MySQL database now, and that's just how it's going to be, and like it's not going to be able to hurt the other thing. And the other thing I've heard people do is they've actually built tooling and services where you can write just a very large, like not a schema file, but pretty close to one, and it will generate an entire database, deploy the database, and deploy the service in front of it that everything actually communicates through, so that only like one service knows how to talk to the database and everyone else knows how to talk to gRPC foo X or whatever.
Yeah, that's sort of exactly what we do. We are taking a configuration-based approach. So we're basically trying to replicate like what Terraform does with infrastructure, but with our entire data architecture. So we can actually specify the schema, the data quality tests, anomaly detection, whatever, and then also generate the test harness for the actual like API layer, and it's all like in a centrally managed configuration file.
Yeah, I think that's a super cool idea. That's what we do as well. So we try to like compartmentalize everything, but then this idea of putting a service in front of it lets you define like APIs, which people know how to deal with and like how to deal with contracts with. Helps you be able to like backfill things lazily. I think that was something that maybe one of you were talking about versioning your rows. Like that's something that like all of your services need to know how to do. They can just have this one service be in charge of it. So that's definitely a pattern that we found super nice. And another benefit is like eventually, yeah, you can like shift away from having a relational database and put it into a SQL database if you want without the other clients having to know. So.
One more comment on that. One of the things that we've actually found is that we've completely inverted the problem, where the hard part isn't moving the data around and getting it into the right shape and have the right values and stuff. The problem actually now becomes on the like in our API layers, because everything we've completely automated and connected every step of the process up to the point where you have to write the code. And if you follow the coding standards of whatever framework, it turns out like it doesn't. You actually break your code from like the API level. And so that's the actual challenge that we're facing now, is like, how do you stick with these like rigid requirements in Spring Boot and how you write code, whatever, to work with that sort of very dynamic way of doing things.
And one thing that we kind of tried out was thinking through like just a couple of more common scenarios that you might run into. So even if something as simple as I want to add a new column onto this existing table, how do I go about doing that? How do I backfill the data? Should the data be backfilled at all? And once you that's the way that we kind of approached it when I was working at Farm Credit, was let's kind of identify this particular problem and let's solve that, and then we can kind of share the lessons that we learned by doing something like that. Because I mean, each tool is going to be completely different. Each language and how you approach that, each ORM is going to be so different on how you solve that particular problem. It's like any framework may or may not like that, whereas Dapper is like, yeah, that's cool.
Somebody have anything else to say? All right, I'm gonna hit. Oh, yes.
I just had one question. Is anybody doing any predictions on how long a given transformation is going to take? So we always have the usual issue of dev and test and QA are 100,000 rows and production is 50 million rows. Are you doing any extrapolation? Have you successful extrapolation of it takes 2 minutes here, it's going to take 12 hours there?
I'll answer. So yes and no. So yes, we've done that, but we also found that extrapolations were wrong. And because so if you've gotten deep into the SQL side and you had to like execute like query plans and stuff like that, especially dynamics first, because they keep adding features. But like we had a situation where based on the first person to basically create the query plan, their data was so much more significant than other customers that we had to make sure actually who made the initial query depended on the performance from there. So like we thought it was like, oh, this can perform fine, but because the way everything was generated, it was not right whatsoever. But trying to get a 500 terabyte database cloned was not exactly an option either. We kept a lot of data.
So in one company I worked at, we would do that with production data. It was a copy of production data where we had anonymized everything, so that we had that process automated, and it would run on a regular schedule. So our test or dev database was always basically a couple days or a day behind production. So we had the ability to test that beforehand, like how long a migration would take.
Getting after half a petabyte of space was hard though.
Not on the cloud.
But I mean, back to some of the points have been raised that you should probably be doing some of this in the API layer, like you're mentioning that, and have the code kind of handle those migrations for you. At that point, it's more along the lines of how long until all the records have been hit by the API to adjust the data to the appropriate version. And that part's going to be a little bit trickier, as opposed to I'm just going to run a migration script that's going to take this data from column A and table A and over to column B and table B. You could probably, within 10, 15 minutes, hopefully get pretty close to that, but with code, it's going to be a lot trickier.
So we just have a couple minutes left. I want to make sure we get at least a little bit on the third question. What would you want to see in 2 to 5 years? So what would make this whole process better?
Automated rollbacks.
That's exactly what I was going to say.
Everyone in the world has asked me that question. How do you roll back the data?
You know, what I was gonna say is like everyone always talks about automated rollbacks and stuff like that, and that was that conversation I brought up in the beginning. Is like it really doesn't exist because like once you get to like, all right, we have no idea how to bring this data back, and if so, like no one wants to, so it's like kind of a like at least my opinion. Sorry if I insult anybody with this, I don't mean to, but like maybe we should just abandon the idea of rollbacks and call it roll forward.
Rollbacks be created as the code's being created. So as you're making your changes, then you have a rollback to also.
With data manipulation though?
No, not with data. With schema.
That's the key.
Yeah, that's the unfortunate thing is once you create a backup, once a user, customer, whatever gets into the data and makes one change, that backup's essentially worthless. Because if you add a new column, if you roll it back, what do you need to delete the column? It's like you're going to lose a bunch of data. That's not probably an acceptable answer at that point.
Yeah, no, I definitely think that it's a cultural shift to get away from the idea of rollback, which, like when we talk about CI/CD, there's this whole thing of like, oh, you should be able to roll back with a click of a button at any point in time. But with data, you have to structure your whole work to roll forward.
Exactly.
And there's no other way of doing it. Like if you don't have your plan set, that if something breaks, you can then fix it in some other layer.
You got like 4 times as much work to do planning for a rollback on data than you do on anything else.
Yeah.
And that's assuming it's going to be successful.
Right.
So 2 to 5 years, I'd like to see us move from, instead of here's some SQL that will get this thing into the right state and we'll then be at version whatever of that, I'd like to see a more Terraform approach of this is what this thing should look like and the tooling helps work out how to get there. Mm-hmm. So desired state for databases instead of here's a bunch of steps that might get you there.
I mean, there's some tooling out there, but it'd be nice if it's more open source. I guess is probably the more appropriate answer. That
SSDT is complex.
Yeah, SSDT. I mean, Reg8 does that for you, but and it's a great tool, but it's also you're paying for that. You're paying for that expense, and it's only for SQL Server and MySQL. And so, what about all the other databases out there?
I was going to add one thing. So SSDT, for example, like if you set it up the way they want you to, it's everything from the logins to the users to schema. Like you can set up literally everything you want in the SQL Server because there's 2 different types of projects in Visual Studio: the database project and the server project. And the server project is more your DSC, but like a lot of people don't use those as much. We had to start using them at JP Morgan. But that would be something to look at too. Is that's kind of like there is a tooling out there that does it. It's just I hope the documentation's gotten better. But it's there.
I just want a schema migration tool or version management tool that is Git aware, because I already have a version history, and it's right there. Just walk the Git tree and build it in the order that was done. And
oh, I got you. So it's going through your Git commits then, and it's just looking at what changes were made.
yeah, I mean
That's pretty cool.
Yeah, that would be nice. Like we use Flyway for stuff now, and I'm still annoyed that I have to and then a number. It's like this is a solved problem.
So thanks everyone for coming. Great discussion, and now we have a break. So thanks for coming, and thanks again to Bob. Thank you.